Okay, let's just look at the first example in here. Okay, so before you find this dz okay, you have to analyze whatever that you have been given in the questions. Okay, we begin with the z. Okay, so you have the z. Okay, in the z, what you have here is you have variable x and y. So instead you have two branch. One branch is for x, another branch is for y. Okay, x and y, two variable, right? Okay, so it means that you have two branch. Okay, so after that, you're going to do partial derivative. Okay, one is with respect to x, one is with respect to y. Okay, after that, look at here. Okay, so in the x, you have another equation. The equation is actually one variable. The variable is t only. So t only. Okay, because the equation x only has one variable, so that is we're going to differentiate directly. So we have dx dt. Not partial anymore. Okay, so same thing happened to the y. You have one variable, that is variable t. That is variable t. So then this is actually dy dt. Alright, okay. So now you're looking for dz dt. So you have to note that is ending with t. So means that you have to plus with these two branch. Two branches you have to plus it together. But before you plus them, okay, so please find this all first. Okay, this all. Now we need the information before we proceed. So let's begin with this. Okay, so let's just find del z del x first. If you're talking about del z del x, it means that you actually treat y as constant. So we have y as constant. So refer back to here. Okay, so so you have non. So the formula for non, if you differentiate, that is actually 1 over g. So that is 1 over your g. Your g is actually x square plus y square. Okay, and then multiply with g prime. G prime, this is your g, and g prime. Okay, differentiate with respect to x now, and y is constant. So this is, you can differentiate, but this is constant. So you will have 2x plus 0. So don't have to write the plus 0. So we ending as 2x x squared plus y squared. Okay, let's just look at another one. We're going to look at this one. So we have um, del z del y. So we're going to treat x as constant now. X as constant. We're going to repeat the same process. Okay, so we'll look at the z. So same thing. You have 1 over g. So your g is x squared plus y squared, and differentiate this function g. So this is actually 0 here, this is actually 2y. So you have multiply with 2y. So ending you have 2y divided by x squared plus y squared. We're done for the top, okay? So let's just go down here. So you need to find dx dt. Look at this, okay? So you have x, look for dx dt. So differentiate this with respect to t. So this is actually give you minus e minus t. Okay, and then we need to find this. So we have to find dy dt. Look at the y, differentiate to t. So this is actually give you dt. Alright, okay, so now we're interested to find dz dt. So according to what we learned in the video, it says that actually, okay, you're going to plus all the branches that you see. But each branch, the thing that you see in each branch, you have to multiply. The first that is this, we're going to multiply this. We have del z del x multiply with dx dt plus, okay, another branch that is this one. This is the one. So we have del z del y dot with dy dt. This is another bunch that is ending with t. Okay, we're interested to ending with t, right? Okay, so now do the substitution as usual. Okay, we're gonna do the substitution. Okay, del z del x is actually give us 2x over x squared plus y squared. dx dt, that is minus e minus t plus this one. Okay, this is actually this 2y x squared plus y squared dy dt, that is this one, that is et. Okay, it's basically I've just do the substitution. Okay, and then you can see that basically I have things that I can factor out where I have things in common. Okay, that is I have a 2, here. I have x squared plus y squared, I have x squared plus y squared. So basically, why don't we just factor out the things in common? Okay, so you will see I basically have this. Okay, I factor out. Okay, after I have factor out, I will remain something in the bracket. Okay, so I will have the x and minus e minus t, right? So I'll multiply, I will have minus x e minus t. Okay, at this part I will have y e t here, y e t. Okay, but don't stop, don't ever stop your answer in this part. Okay, because your answer should not consist of x and y anymore, because it's just differentiate with respect to t, so your answer should be in t only. So let's just check back just now. Okay, what is our x and y? You have to change it. It's just that all of them is actually in terms of t only. Don't leave it this way, right? Okay, so go back to just now the question. The question says that the x is e, minus t, the y is e t. Okay, so let me drag down this one. So later we can refer to it here. Okay. Okay, we need this information in order to have only t. In the final answer. Okay. So now okay, let's look at the x. Okay, what is your x here? Your x here is actually this. Substitute with this. Okay, so we have e minus t. Okay, and then we have a square here. We have a square here plus y. Okay, what is your y here? Well, your y is this one. Your y is et. Okay, so y is et. Okay, we have a square here back. Okay, so x and y. Okay, same thing happened to here, whatever is in the bracket. So we have minus the x. The x is actually e minus t. Okay. Then this one we copy back. We have e minus t. Okay, plus the y. The y is actually your et. And you have the et here again. Okay. This is the y. Okay, so basically just do the substitution. Okay, after you have do the substitution, you can see that basically all the x, y disappear. We only have t inside the equation. But simplify it. Okay, simplify it. All right. Okay, let's just simplify it. So we have 2. Okay, over. Okay, this one you can multiply. If you multiply, you have e minus 2t. Multiply, you will have e 2t. All right. Okay. How about here? We have minus, but this one is in here it is a square. Okay, the index you should multiply. When you have a bracket, you have a square. Okay, the index and index you multiply. Index and index you multiply. But you have two items here. Okay, basically the same item. There are e here exponent. So the index you plus that. So you have minus e plus with minus t. So you will have minus 2t. Okay, so now same thing. Okay, this one is basically you have two exponent here. To the index, you actually can plus because multiply, right? Okay, so you can multiply. Okay, so this is basically e. T plus t is actually 2t. So this is actually the final answer for this question. Okay. Okay, let's look at the second example. Okay, so let's just analyze this. Okay, so in your equation of z, say we have two variables, that is x and y. Okay, so because you have two variables, you're going to do partial. So you have del z del x, and you will have del z del y. Alright, okay. And then how about the x? The x you have two branches also because you have s and t. You have s and t. So in here, because you have branches, we'll do partial. So this is del x, del s. This is del x, del t. For the y, same thing. Okay, you will have two branches. Okay, and with two nodes. Okay, the nodes will be s and t. So this one will be partial. So this is del y del s, and this is del y del t. Okay, before we proceed this, okay, why don't we figure out for each partial derivative, what is the equation for each partial derivative? Let's just go for this one first. So we have del z del x. Okay, so you're going to treat y as constant. So you treat this y as constant, you will differentiate this. So if that way means that you have ex sine y because the y is constant. Okay, then we'll treat by del z del y. Now we're going to treat x as constant. So you differentiate this. To differentiate this, you have cos, right? Okay, so e is the constant. So we have to differentiate the sign. So we have cos y. So that is for the first branch. Okay, and we have to go down. So we go for this one. Okay, so if you look at that, okay, so del x del s. So we have to refer to the x. So we have del x del s. So means that you differentiate with respect to s. T is constant. So differentiate s, you has 1. So this is constant. So we have t squared. Okay, and the next is del x del t. So that is that t that is treated as constant. So differentiate this. So we have 2st. Okay, go for the last. Okay, so we have del y del s. So refer to this. So differentiate to this. So we have 2st and del y del t. So differentiate to t. So we have s squared. Alright, okay, so now, okay, let's just look at the first part. Okay, we're going to look for, okay, the first, that is this. So we have del z, del s. Okay, so if we refer to the diagram will help us in order to answer these questions. So we're talking about differentiate with respect to s. You're going to look at the node that involved with s, and we will analyze the branch. Okay, so in here, so we have this one, the branch. Okay, along the branch you can see the partial derivative by that. That is, we're going to have the thing multiply together. So we have del z del x multiply with del x del s. Okay, so you must multiply down. Okay, plus with another branch. Okay, so another branch that is involved with s, that is here. This one and this one. We go down like that. Okay, and then this is actually you have to multiply as well along the same branch. Okay, so you have del z del y dot with del y del s. Okay, let's just do the substitution. So del z del x, that is this one. So we have ex sine y. This is actually here, t squared. Okay, plus with this is this one. Ex cos y, and del y del s is this. So we have 2st. Alright, okay, let's just simplify it. Okay, so if you simplify it, so we will have that is t square. Okay, we have a t square, and we have ex sine y and this is actually 2stex cos y. And again, we don't leave our answer in x and y because we're actually looking for the partial in s. So if we're looking for partial in s, okay, so all those are not related to the s, you have to change it, but we will keep the t together. We'll keep the t because the t is actually in the same level together with the s. Okay, we'll keep the t and s, but the x and y, you have to change it. Okay, where to change it? We go back to here. Go back to here. Okay, t will keep it. So we have t squared, but the x here is this one. So we have s t squared, and the sign, the y here, this is the one, the y. So we change it. So we have s squared t plus 2s 2st ex again. X is this one. We have st squared and cos y. Cos y, that is sine squared t. Okay, so that is for this one. Okay, so could you try on this one? Okay. Let's just try on this one. So we're looking for del z, del t. Okay, what happened to the chain? Okay, you figure out what's the chain. Okay, look at the diagram. The diagram will help you to write the chain. Okay, you can pause the video for a while and look for the correct chain rule formula. Alright, okay, so let us see what happened if we're looking for del t. So look at the t node, So along the branch that you have t node, that is this one. So means that you will have the first branch, that is del z, del x, multiply with del x, del t, okay, plus with another branch, that is this one. Okay, so that is del z, del y, plus with del y, del t. Sorry, it's not plus, sorry. It is actually multiply, okay? It's del y, del t. Okay, done. We don't need it anymore. Let me push it out a bit on this. Okay, can you do the substitution? Can you try to do the substitution and see what happened to the result? Okay, can you try on it? Okay, and see what happened to the result. Okay, you can pause the video for a while. Okay, I'm going to give you the final answer of this one. Okay, the final answer on this one will be 2 st e st squared sine s squared t plus s squared e st squared cos s squared t. Okay, so you should able to get the answer after you have substitute, simplify. Okay, don't forget to substitute the value of x and y into that. Okay, after you have substitute, just repeat the same process as what I did just now. Okay, you multiply, simplify, and sub by the x value and y value and see whether you're able to get this one, right? Okay, let's look at the last example for the chain rule. Okay, so same thing. Okay, we're gonna analyze this one. Okay, so we have exact. So we can see that we have two variables. So we have two branches. So that is x and y. I'm not going to write the partial, okay, because we only find one partial derivative. Okay, let's just analyze this. Okay, so in here, okay, look at the x. Okay, what the x has? The x has u and v. Okay, so we have u and v. Same thing happened for the y. It has u and v. So you have u and v. Okay, let's look at the things they asked us to find. They asked us to find del z, del u. So means that the one that you look for is actually the node that is ending with U, ending with U. So you just have to figure out what is the partial derivative along those branches. Okay, so we don't have to find the V, right? Okay, so we just have to find whatever that is involved with U. Okay, so in here along the line we will have del Z, del X, and this one will be del X, del U. Okay, how about this? This is actually del Z, del Y, and this del Y, del U. Okay, first of all, let's just find this one first. Okay, so this you can obtain from here. So you're looking for del Z, del X. It means that you treat Y as constant. Y is constant. You differentiate EX. So what is the answer? Okay, this is constant. So means that you will have Y, E, X, Y because you treat Y as constant. Okay, how about next? So next you're looking for the del Z, del Y, del Z, del Y. So now you're going to treat X as constant. X is constant. So means that you have X, E, X, Y. Alright. Okay, once you have that, okay, let's just go down. So you need del X, del U. So del X, del U can get from here. So you have del X, del U. So treat V as constant. Differentiate this. So means that you have 2. Okay? So do we need to find del Z, del V? No, because you don't have to find it because we don't need it. Okay? What we need is just del X, del U. So don't go and buy this. We don't need it. Okay? So even though if you buy it, we also don't give you any marks on that. Okay? Because it's just required to find one partial derivative. Okay? Okay, what is the last partial derivative that you require to have? That is this one. Okay, that is del Y, del U. Okay, del Y, del U that is getting from here. Okay, in order to differentiate, okay, try to mix it into a way that easy for you to do the differentiation. So U over V can think of as V minus 1. Okay, V power of minus 1. And remember, when we say differentiate with respect to u, that means that v is constant. V is constant. Okay, so you differentiate this, but this is constant. So you differentiate u, you will have 1. 1 multiplied with this constant. So you will have that constant. That constant is v minus 1. So that is actually 1 over v. Alright, okay. So that is the thing that we require to have, okay, before we build the chain rule formula. So let's look at the chain rule, okay. So we have to find del Z, del U. So del Z, del U can obtain from these pictures. That is the first branch that you see, that is del Z, del X multiplied with del Z, del U plus with the second branch we have del Z, del Y, but with del Y, del U. Alright, okay, so let's just do the multiplication. So this is actually Y, E, X, Y. And it's 2. This one is X, E, X, Y. The del Y, del U, that is 1 over V. Okay, and let's simplify it. Okay, so when we simplify it, this is actually 2y e xy plus x e xy over the v. Okay, let's substitute the x and y into here. Okay, remember we cannot leave our answer in terms of x and y because you are having partial derivative to with respect to u. So what you can keep in the equation is actually u and the variable that is in the same level with the u that is a v. You only can keep the u and v into this in this equation. Okay, for those x and y which is a higher level, you have to change it. Okay, So you have to change the x that you see in here and the y that you see in here, change it to u and v. So just change it, okay? So okay, let's just do the substitution. So in here you have the 2, okay, the y there is u over v, the x there is bracket 2u plus v, again multiply with the y that is u over v, okay, plus with x e x again, so that is 2u plus v, and then the y is u over v. Alright, okay, and then over with the v here. So basically we just do the substitutions on the y, okay, list of substitutions. We have the y here, we have the y here, okay, and do the substitution for the x, is the x. Oh, I forgot to change this. This is actually supposed to be x also. Okay, so that is 2u plus b e 2u plus b, the y is u over v. Alright, okay, so then let's see, okay. So this is your y and your x. Your x is here, it is your x, this is your x, right? Okay, done. Okay, so after we have after we have do the substitution, and then let's just simplify it, okay? Let's just simplify it. Alright, okay, so for the first part we will have 2u exponent, okay, bracket 2u plus v multiply with the u divided by the v, okay, over with capital over with the v again, okay, and then the same thing happen to here. We will have 2u plus v, the exponent again is 2u plus v multiplied with u over with v and over with v again. Alright, okay, and you can see that we have the same numerator. So basically we have the same numerator, you can group them together. So just write 1 times v, you know. So you just have to write 1 times v now. V, and basically this is actually, I'll just rewrite it back. So I have 2u e 2u plus v u over v. Okay, I can expand this. If I expand this, I'll have 2u e 2u plus v multiplied with u over v plus expand it. So we have v e 2u plus v u over v. Okay, and then you can see that basically I have seen item in here. So u and exponent, u and exponent. Okay, so what you can do is you can group them together with plus. Okay, so we will have 4u and exponent. So we will have 4u exponent 2u plus v u. That is u. This is u. Oh. It's 2u plus v u over v plus with this item, so v e 2u plus v u over v divided by v. Alright, so that's the answer for this example.